Hello, welcome back to another presentation on the DevOps Handbook. This is CIT 262. We are Group 7, Brittany, Herrera, Alexandra, Lozano, and Eddie Pincay. This week we will be going over Chapter 15, which is Analyze Telemetry to better anticipate problems and achieve our goals. All right, so we're going to be talking about tools and techniques and ways to analyze things so that we can prevent and solve our problems faster, cheaper, and earlier than ever. So this is a great chapter for techniques. An example of this is Netflix. So Netflix used outlier detection to compute what wasn't the current normals right now. And the benefit of using these techniques to preserve the employee sanity, work-life balance, and service quality cannot be overstated. So they basically, by implementing the server outlier detection, Netflix reduced the effort of finding 6 servers and reduced the time required to fix them. And so use means and standard deviations to detect the potential problems. For instance, we might set an alert for when the number of unauthorized login attempts per day is 3 standard deviations greater than the mean. Provided that this data is set the Gaussian distribution, we would expect that 0.3% of the data points would trigger the alert. And even this simple type of statistical analysis is valuable because no one had to define a static threshold value. Something which is infeasible if we are tracking thousands or hundreds of thousands of production metrics. So a common use of standard deviation is to periodically inspect the data set for a metric and alert it if it has significantly varied from the mean. All right, instrument and alert on undesired outcomes. If we had an issue where our web server stopped responding to requests, we would look at the leading indicators, the application level, the OS level, database level, and network level. For each, we would configure our alerting systems to notify them when they deviate significantly from the mean, so that we can take the corrective action. Each of these metrics is a potential precursor to a production incident, so we pay a lot of attention to these things. So problems that arise when our telemetry data has a non-Gaussian distribution. When the distribution of the data sets doesn't have this bell curve, the properties associated with standard deviations do not apply. The obvious problem that the graph shows is that when we're alerting most of the time, and this is because any given period of time we have instances when the download count exceeds our 3 standard deviation threshold. This shows the frequency of downloads per minute. It didn't have the classic bell curve shape. Instead, it's obvious that the distribution is skewed towards the lower end, showing the majority of the time we had few downloads per minute, but that the downloaded counts frequently spike 3 standard deviations higher. And another case study was the auto-scaling capacity at Netflix in 2012. Scryer addressed some of the shortcomings. It addressed, the first was dealing with the rapid spikes in demand. The second was, after outages, the rapid decrease in customer demand led to removing too much capacity to handle future incoming demand. And the third problem was that the AAS didn't factor in known usage traffic patterns when scheduling the compute capacity. Skyer worked to predict what customer demands would be based on historical usage patterns and the provisions and necessary capacity needed. So here's our two examples. Netflix took advantage of the fact that their customer viewing patterns were surprisingly consistent and predictable. Despite not having the Gaussian distribution, above is the chart reflecting customer requests per second through the work week, showing that regular and consistent customer viewing patterns Monday through Friday. And Skyer used a combination of outlier detections to throw out the spontaneous data points, and then used techniques such as the fast Fourier transform and linear regression to smooth the data while preserving legitimate traffic spikes that recur in their data. The result is that Netflix forecasts traffic demand with surprising accuracy. Only months after using Skyer in production, Netflix significantly improved their customer viewing experience, improved service availability, and reduced the Amazon EC2 costs. So it really, really helped this company. Then we have using the anomaly detection techniques. Anomaly detection is the search for items or events which do not conform to an expected pattern. Smoothing is a statistical technique which is especially suitable if our data is a time series, meaning each data point has a timestamp. It often involves using moving averages, which transform our data by averaging each point with all the other data within our sliding window. When our data does not have the Gaussian distribution, we can still find noteworthy variances using a variety of methods. These techniques are broadly characterized as anomaly detection, often defined as the search for items or events which do not conform to an expected pattern. Some of these capabilities can be found inside our monitoring tools, while others may require help from people with statistical skills. So we have a case study, advanced anomaly detection at Monotrauma in 2014. Dr. Bobes described the power of using anomaly detection techniques. Using this Kolmogorov Smirnov test, a technique that's often used in statistics to determine whether two sets of data differ, and it's found in the popular graphite and Grafana tool. So Dr. Bobes described that this tool could help them, and the purpose of presenting this case study is it's not a tutorial, but it's to demonstrate how a class of statistical techniques can be used in our work, as well as how it's likely being used in our organization. All right, this picture shows a data set with the KS filter applied with a third area highlighted, the anomalous Mondays where transaction volume didn't return to normal levels. Basically, this would have alerted us of a problem in our system that would have been virtually impossible to detect using visual inspection or using standard deviations. In this scenario, the early detection could prevent a customer impacting event, as well as better enable us to achieve our organizational goals. All right, so conclusion for this chapter. There's lots of case studies that are talked about and tools and techniques used that can help us prevent getting problems and help us to analyze where the problems are coming from and solve and fix our problems earlier, quicker, and cheaper than before. It was a great chapter, some great techniques to look at if you're currently in the market for that. Let us know if you have any question. We enjoyed doing this presentation and looking forward to doing another one next week. Thank you, and talk to you next week.